Hi, everybody. It's really good to see people in person and have depth to looking at people's faces. I've been asked to talk about 5G technologies as applied to IoT space, right? Oh, we don't want to look at him. Let's start with a little bit of history so we know where we're at and we know what exists for 5G. You know, way back when you had the analog phones, we'll call those 1G. And then there was 2, 3, 4, and now we're at 5G. And you know, each one of these hops took about 9 years. So, you know, 9 years from when 5G is released, there'll probably be a 6G, right? But the key thing I want to focus on here is the 4G, the LTE world. See, back then, at that point, they came out with LTE, which is long-term evolution, and the cellular world divided services into two main categories. And you see one arrow going up there, and it says LTE MBB, and that stands for mobile broadband. That was targeted to users like you and me with our cell phones, right? High speed, strong connectivity, right? Those sorts of things that our cell phones use every day. And then on the lower side, they had LTE MTC, which stood for machine type communication. That was targeted more to low data rates, small amounts of data, right? Infrequent operation, those sorts of things. And those are the IoT side, right? As we probably all guess. Well, what happens is those were pushed forward, and now we have 5G. And in the 5G world, they created 3 different categories of service. We still have the MBB, the mobile broadband. They call it eMBB for enhanced. And then now they added a new category. It's called URLCC. That stands for ultra reliable, low latency communication. That group of services, that category of services, is targeted for some industrial IoT applications, but also critical infrastructure kind of related applications, applications that fit somewhere between your cell phone and a very simple IoT sensor. And then they preserved the machine type communication, but you know, they had to add something like an E or an M, and so they added M for massive machine type communication. So we now have these 3 categories of services. And the reason why I want to go through these is they all are fairly separate now, but they're starting to merge together. The ultimate vision is to have them all merge together. So I'll start with enhanced mobile broadband. That's your cell phone, essentially, right? And you're going to get super high data rates, I think now at what, Cat 20 gigabit per second. You're also, though, going to get really high capacity, not only for all that data, but for all the people that are going to be using the data that often get together. So imagine going to a sports venue, right? There's 100,000 other people there. You're all going to be looking at your cell phones at the replay, right, while you're watching the game. So that capacity is really important. But there's another thing of enhanced mobile broadband, and that is you, and where your phone is, and what you're doing with the phone. And the networks use that to provide better service to you. Many people don't know that. The other category is mission critical control. That's that URLCC thing, right? The thing about that is there are a lot of applications, especially remote control applications for perhaps critical infrastructure. Maybe you're monitoring a generator or a power plant or something like that, and you absolutely, positively need to talk to that device or that system when you need to. So you need to be ultra reliable. In addition to that, if you're doing remote control, you often need to do things quickly. And so the low latency part allows the network and the device to interact faster than has been in the past. That allows you to see, for example, something bad happening and taking an action to avoid that from the network instead of locally. But the other thing is, that you may not know about in the ultra-reliable part, is being able to move quickly with your cell phone. I don't know how many of you have ever been on like a bullet train and lost cell service. And it's not because your phone can't hear a tower. It was because your phone can't keep up with the tower changes, or the network can't keep up with you switching towers. So in 5G, what they did is now you can go up to about 500 kilometers an hour and still maintain that handoff from tower to tower as you're traveling. So that's great, and the reason why mission-critical control type applications are there, a lot of industrial IoT applications fall right in that sweet spot. Then the last thing is listed there as massive Internet of Things. You heard me just say it was enhanced machine type communication. There, you're much more concerned with having a connection that might be in a basement, right? Might be in a difficult place to reach. So deep coverage and signal propagation is extremely important in this area. You need to have the radios be as simple as possible, because for all those billions of devices that are supposed to be going out there, we cannot be spending a large amount of money to do that, right? So these devices had to be really inexpensive. So the radios had to be really simple. And the services need to support the billions and billions concept, right, of sensors in the field, so that we can achieve the promises of IoT in many ways. So these are the three categories that make up the cellular world today. But what we need to focus on is machine-type communication, right? Now the GSMA, there's so many acronyms here, so I apologize for that. I'll try to keep it as simple as possible. But the GSMA refers to all this as mobile IoT, or MIoT. 3GPP refers to it as LPWA, low power wide area access, or network, or whatever afterwards. In any case, these technologies have similar characteristics for IoT. They want to use low power. They want to be very simple, just like I said with those category definitions, right? They want to have scalability and all these things I've listed here. I won't go through them all, but all of these together tend to characterize what we're going to call LPWA, or IoT, in the cellular world. So this is a really old slide. It's actually one of my oldest slides. And it's funny because the technologies for 5G actually came out in 2016. I don't know if that surprises you at all. You've probably all heard of LTE-M and NB-IoT, right? LTE-M stood for LTE, for machine-type communication, and NB-IoT is narrowband IoT. Those were actually introduced way back in 2016. So they've been around a long time. But like everything in the cellular world, they are enhanced and developed with each new release. So today, they are much better, more capable than they were when they were released. However, it's important to note that those two technologies are the primary IoT technologies for 5G, and they were first introduced in 4G. Now, if you look there, you're going to see some things like FEMTC and EFEMTC. You know, they're very creative in their naming their things. EMTC was enhanced machine-type communication. FE is further enhanced machine-type communication. And EFE is enhanced, further enhanced machine-type communication. These are all not used anymore, but that just shows you how old this slide is. So the features of LTE-M and NB-IoT that apply to use in IoT solutions and systems were actually brand new for the cellular world. And they're completely different than the mobile broadband approach. And the first one is power saving mode. Now, what you may not realize with your cell phones right now is they are talking to the network back and forth. That's one reason why your battery only lasts 24 or 48 hours on your cell phone. There's a lot of signaling and stuff happening between your phone and the network all the time. You can't do that with IoT sensors, right? On the IoT world, you want a sensor to sleep as much as possible, because when it sleeps, it doesn't use hardly any power, and so as a result, its battery can last a lot longer. Hence power saving mode. Power saving mode is very simple. The device just goes to sleep, and it uses very little power. The good thing about that is a device then can have a small battery and last a long time. The bad thing is that when the device is asleep, the network can't talk to it, right? It's kind of disconnected from the network. And so that's what we call a high latency relationship between the network and the end device. And that's great for things like a water meter that wants to wake up once a day, send a reading, and go back to sleep. That works fine. However, there are a lot of applications where you may need to reach out and talk to the device, and it might be important. And so an intermediate step between having your cell phone and being asleep all the time is a thing called extended discontinuous reception, or EDRX. All this really is that a device, instead of sleeping, it's going to sit listening. Now, for most, though I'm sure most of you know that IoT sensors, when they're sleeping, they use little to no power. When they're transmitting, they're using the most power generally, right? Now, in receive mode, you often use about 10% of the transmit power. So 10 times less power if you're just listening, but you're not asleep. And when you're asleep, you can use 100 times less than just listening or receiving. So EDRX allows a sensor to sit there and listen so that if the network wants to talk to it, it can. It's going to use more power than if it was sleeping, but a lot less than if it was transmitting. And some of the other changes they made are, at a very fundamental level, give you what they call extended coverage. Well, what does that really mean? The frequencies that are being used are generally sub-gigahertz. And physics tells us that sub-gigahertz frequencies really travel far very easily. So if you're outdoors, a signal that's based on sub-gigahertz frequencies is going to go a lot farther than, say, Wi-Fi. And if you're indoors, that same signal will penetrate very deeply into the building, again, compared to something like Wi-Fi. So what they've done is they use different frequencies, and they made the devices give a little sharper hearing. We call that receive sensitivity, okay? And so the difference between how much you can transmit, how much power, and how sharply you can listen, the receive sensitivity, that difference is called your link budget. And in the NB-IoT and LTE-M world of cellular, they grew that link budget so that your signals could go much farther or penetrate much more deeply into a building. The key difference between LTE-M and NB-IoT, as you can see there, is LTE-M has a higher data rate, but it also supports voice and SMS, whereas NB-IoT does not. And LTE-M has the ability to be mobile. In other words, it can be handed off from cell tower to cell tower, whereas NB-IoT devices, no, they don't. They connect to a cell tower, they establish a session, and that's where they need to stay. So after release 13 in 2016, that long ago, they've enhanced these LTE-M and NB-IoT capabilities, right? They've added the ability to hand off LTE-M much simpler, much easier, so it gives you better mobility. For both of them, they added the basics of device positioning, which for those of you who deploy IoT solutions, you always love to know where that device is, right? And being able to do so without having GPS or GNSS circuitry in the device saves you a ton of power and a fair amount of cost. And being able to just use your cellular radio signal to do that is a big benefit. That was added. It's a rough positioning, though. It's nothing like, 10-meter accuracy. It's more like 50-meter accuracy, but it's there. On the NB-IoT side, they made some improvements to how it talks to the network, so you can have NB-IoT devices functionally much farther now from a cell tower in the presence of other cell towers and not cause problems. The point with this is they continue to evolve and develop LTE-M and NB-IoT as the primary IoT 5G solutions. So where would you use the two? I mean, I've been mentioning them together now this whole time, right? So you might walk away saying, well, they're the same. Actually, they're very different. So NB-IoT, let's start with them. An NB-IoT device is great if you're going to be placing it and not expecting it to move. Think street lights in a smart city, right? A room sensor in smart building, or a moisture sensor in a field in smart agriculture. These are things you generally place, and then they don't move. You use them, and they do their job. NB-IoT is perfect for that. A couple caveats. It has a very low data rate, and so you need to not be needing to send a lot of data. And so what is a lot of data, right? If you're sending more than, I don't know, a few kilobytes of data each time you report, then you're probably not going to want to use NB-IoT. It's really meant for those little bursts of data up to the network. Here's my temperature, here's my moisture, here's the room occupancy sort of thing. In addition to that, there are a number of applications, I hate to say it, like manhole cover monitoring. That's a thing. They get stolen a lot, apparently. Normally, NB-IoT would be great for that, right? How often do manhole covers move? But when they get stolen, you want to track them. So NB-IoT would probably not be a good solution for that. For LTE-M, and this one it's called eMTC, the terms are synonymous. That's great if you're doing things like asset tracking, right? If you're wanting to track a device that is normally stationary, as I just meant, someone steals it and moves it, like a security failover. LTE-M is better also for places where you are going to install a sensor, or applications where you're going to install a sensor, and you're going to start with a certain amount of data, but you want to grow it over time. And that's very typical of IoT systems. And that implies that you're going to be doing firmware updates over the air. And so LTE-M gives you that capability. NB-IoT, it is very difficult and problematic to do firmware updates over the air for an NB-IoT device. You can do it, it just takes a long time and is not very efficient. And remember, the more that device is active, the more it burns up its power in its battery. And so you have to trade these things off. So they're going to continue evolving LTE-M and NB-IoT. Now, there was a lot of concern in the industry when 5G was released. And they said, oh yeah, the IoT side is that stuff that was released back in 2016. There was a lot of concern because you think, well, that's going away, right? So in release 16, which was, what, just last year in 2020, no, 2 years ago in 2020, the 3GPP formally adopted and said, no, these technologies are permanently part of 5G, and they established full coexistence with the 5G NR radio, or I think someone earlier mentioned standalone radios, if you understand that term better. So these technologies are now fully integrated into that paradigm, which means they're not going anywhere. And so device manufacturers can have confidence to make devices that utilize these technologies. In release 17, which is coming out anytime, it's actually, I think it was supposed to come out last month, and they postponed it to July. That's going to further enhance these devices. And how it's going to further enhance the devices is start applying the 5G NR radio. That's all the stuff that gives you that low latency and high speed, right? Ultra reliability. They're going to start scaling that down to IoT devices, and that's in release 17. So that's going to be coming out this month or next. And so the idea with this is they're not going to suddenly go to sensor manufacturers and say, oh, you know, that really cheap not complex radio that you've been using that works on our cellular network. Okay, now you got to use this really complex, expensive one. They're not trying to do that. They're scaling it down to have the capabilities match the needs. And so what are those, right? What are those capabilities? Well, today, in your 5G NR radios, they use what we call wide bandwidths. And when you have a radio that has wide bandwidth, that tends to need more circuitry, more capability. So one of the first things they did is they narrowed the bandwidth. That ends up making the radio simpler. And for those of you who deal with cellular on the mobile broadband side, you know that now there's a proliferation of antennas that's going on, right? Now it's not just 2 anymore, it could be 4, 6, as many as almost you need. And that won't work for a little sensor device, right? You need one antenna, and it's got to be a cheap antenna. So they've reduced that. They're going to half duplex operation, which means that the same antenna can send and receive, and the radio can have one set of components instead of 2, so that it doesn't have to be able to transmit and receive at the same time. It can use this one piece of circuitry and switch between. So it makes the radio much simpler. They've also adjusted things like transmit power and the different power saving modes. I mentioned right earlier about that. They've adjusted those to make them save more power, because NR capability comes at a cost, and they really needed to make sure that your power budget for a sensor doesn't exceed your capability to use this technology. Then the last thing is network efficiency. You know, today, your mobile broadband, your cell phones, the network is all set up to take these huge chunks of data. It could be a website, could be a video, and get that down to your phone. And okay, that's great. You don't need that for a sensor. Sensors are sending little tiny bits of data infrequently. And so the network is being modified to match that, so that it can allow devices to, from its perspective, come and go, and just pop something up there, a small amount of data, and capture it and get it to where it needs to go. And then another thing is the idea, now how do I explain this? It's the idea of you're going to put a device sometime, somewhere, like deep in a basement. So consider a smart building application. You've got sensors all through the building, but you got some that are way down the basement, probably looking for water, right? They're water spill detectors of something like that, water leak detectors. All the devices in the building can get outside and they can talk to the network, no problem. That's great. But that one in the basement can't. It's just too far down. It's too big of a building, whatever. So there are some enhancements that are going to allow for the use of a relay. You probably all know what a relay is, right? Something goes in A and comes out B and vice versa. So you could put a relay there and then get that connectivity down to the basement sensor. But another opportunity is a thing called side link. And the best way I can describe it is, for those of you who are familiar with mesh networks, it's like a mesh network with one hop. In other words, if that lonely sensor in the basement can hear another sensor in the building, but it can't get outside, it can get outside going through that sensor, kind of using that sensor as a relay almost. It's really not quite the same, but it's the best way I can describe it. So with release 17, that's coming out now, these capabilities are going to be available for IoT. Now, they call it 5G RedCap NR. RedCap stands for Reduced Capability, right? And that's what they're doing. They're going to give you lower device complexity, the optimized power consumption. Network enhancements, I mean, that might sound like, oh yeah, that's a big deal. That's a really big deal. The good thing is it has nothing to do with the sensors so much, right? This is in the network, but the network really needs to be reconfigured to handle IoT kinds of data. So that's a big deal. And then coverage recovery. Coverage recovery gives you that higher reliability, right? May not be ultra reliability, but it's definitely higher reliability for your sensors to connect to the cloud. Now, this is kind of shows you how NR started out with mobile broadband, right, URLLC. It's going to be moved into that next tier down, industrial IoT. You see it was called NR Lite. That was the working title. And since then, the 3GPP has formally said, no, it's RedCap. So NR Lite, RedCap, they basically mean the same thing. It's that reduced or scaled down functionality of NR radios for industrial IoT use in that second band. In the next release, release 18, they expect to get the NR scaled down to things like simple temperature sensors and other sorts of very inexpensive sensors you're going to proliferate everywhere. That's going to come in release 18. But the industrial IoT sector is really going to take off using release 17 stuff. So it's a big deal to them. And with that, I am done. Thank you very much for listening.